this video I will show you how to compile and use a small utility I created. It's called patchList, and it lists patches so you can quickly put patches into boundary conditions of an open foam case. So let's first compile this utility. Go to the run directory where I put patchList, as you can see right here. That's the utility. You can see what's inside. There's patchlist.c and a make directory. We'll make some other videos about why and how. Let's first compile patchlist so we can use it on this cavity case. We don't really need it for this cavity case, but I put a different mesh there from another icofoam tutorial of that ships with open foam, and yeah, then we'll see why and how to use it. So first compile it. You just do either change directory into patchlist and do wmake, or do wmake patchlist. See, compile's all happy. There we go. Good. So let's change directory into a cavity case. This is just a copy of the normal icofoam cavity case, with the exception that I put the elbow mesh from the elbow tutorial there. So instead of creating the mesh using block mesh, we're actually going to create the mesh using fluent mesh to foam. Fluent mesh to foam, and then the mesh is called elbow.msh. Create that. So that's all done. You can actually view the mesh already in parafoam, paraview. There we go. I'll just switch off these volume fields because they have the wrong boundary names, and that's why we're going to use patchlist. So this is the elbow case that ships as a ready icofoam tutorial. So we have the normal cavity case, which has moving walls and fixed walls, I think they're called. And here we have some other boundary conditions like 2 inlets and an outlet, etc. This is where patchlist comes in. So if we look at in the 0 directory, there we have a pressure and a velocity file. So if we look, for example, at the velocity, there we go. We have a moving wall, fixed walls, and front and back. But the boundary conditions, or the boundary patches that we just created by converting the fluent mesh, are called differently. So if I just open constant polymesh boundary, so that's just a text file where where the converter wrote the new patches. You can see we have a list of 6 patches, and they're called wall 4, velocity inlet, etc. So of course we can copy this stuff from this file into this file, but it would actually be nice to it would be quicker to have just this part and the brackets, so then we can put in the correct boundary conditions. So I'll show you how that works. Yeah, just go back here. If I now type patchlist, this just prints the 6 boundary conditions we just saw in the boundary file. I'll just copy that, right click, copy, go back to my U file, and then, well, I usually, it doesn't really matter where you do it, but just basically dump them here. I'm going to say, well, these are going to be walls. Oh, that's a wall. What else? This thing is a wall. Sorry. Then there's front and back, which is empty. Like that. And then we have a bunch of inlets where we can specify something else. So let's just put a fixed value there. We have an inlet here, an inlet there. I think this is in plus X direction, this is in plus Y, so it's just for the sake of demonstration, put this here, and this can be some kind of outlet condition, like for example inlet outlet. inlet value uniform. So what this does, this condition, it's a mixed Neumann and Dirichlet boundary condition, which means that in this case, out of the domain we have zero gradient, and into the domain we have a fixed value, this one to be precise. So we let everything out, nothing in. Okay, now that's it. Get rid of this thing here, and then we need to do the same thing for the pressure file. So just copy that, boom. Then we open 0.p like this. Okay, then obviously we'll have 0 gradient at the walls, so we have one wall here, and we have one wall there. At the outlet we'll fix the pressure, so we'll do type fixed value, value. It doesn't really matter what we put there, it's incompressible, it's all relative anyways. And then at the inlets we put 0 gradient. There's also some more sophisticated choices for boundary conditions, but that's not what this tutorial is about. Then we get rid of the old boundary conditions, and there you have it. Of course, it's not a Nobel Prize winning utility, but it saves you, especially with some larger cases, and when you actually start using Snappy Hex Mesh with a bunch of patches that come from some cat package or you might not have created yourself. This can save you some time and typing. So now we should be able to type icofoam. There we go, and it will run happily. Let's see. Well, there we go. Boom. That's it. Hope it's helpful, and well, drop me a comment if you liked it. Thank you.